Alright, in this video we're going to talk about a quadratic function in what we call the standard form. Now, most books at least refer to this in the standard form. There is another form of quadratic equations, which I'll do another video where I talk about that other form, which usually we call the vertex form of a quadratic function. Some books, though, call that other form the standard form, so it can get kind of confusing. So depending on what book you're using, the terminology they use could be different. But what I'm calling the standard form here is f of x equals ax squared plus bx plus c. Right, so a quadratic function is a polynomial function of degree 2. Right, degree 2 means that the highest exponent we have is that second power. Right, so this is a basic form or the standard form of a quadratic function, ax squared plus bx plus c, where a is not equal to 0. Right, and the reason we have to throw that in there, that a is not equal to 0, is that if I had a 0 for a, it would be 0 times x squared. And 0 times x squared is equal to 0, which means we don't have an x squared, which means we no longer have a second degree polynomial. In that case, it would just be a linear function, right? Bx plus c with that x to the first power. So in order for this to be quadratic, we have to have the x to the second power. There has to be a term here so that a cannot be 0. Right? So b and c could be any real numbers. B and c could be 0. A can be any other real number besides 0. All right, so that's the standard form of a quadratic function. At least, like I said, most books refer to that as a standard form, and most teachers refer to that as the standard form. All right, so if we graph a quadratic function, the graph we get is what we call a parabola. A parabola is something that looks kind of like this. It's like almost like a U shape, but not like vertical sides. It continues to open outward as you go. Maybe think about like a rainbow is kind of like a parabola shape, just facing downward. All right, so the graph is a parabola with vertex. The x-coordinate of the vertex is given by the formula negative b over 2a. Right, where the b and the a here refer to these coefficients of the x and the x squared in that standard form. Right, so if I take that coefficient of the x, the negative of that number, divided by 2 times the number in front of the x squared, that's going to give me the x-coordinate of the vertex of the graph. Right, and then the y-coordinate of the vertex is f of negative b over 2a. Right, which basically means once you get the x-coordinate here, take that x-coordinate, plug it back into the original function in place of the x, calculate it, that gives you the y-coordinate of the vertex. Right, and the vertex of a parabola is either the maximum point, the high point if the parabola is facing downward, or it's the minimum point, right, the low point if the parabola is facing upwards. Right, so the vertex is either the high point or the low point on the graph of the parabola. Whether it's the high point or the low point, the formula to find the vertex is exactly the same. X equals negative b over 2a. That's an important formula to know. So if you have like a downward facing parabola and you want to find the maximum point, like let's say your parabola represents the profits you make from selling a certain number of things. Well, if you want to find your maximum profit, you're looking for that high point on the graph. This is how you find that high point on the graph. Right, so there are a lot of applications where it's useful to find the vertex of a parabola because it represents either the highest point or the lowest point. If you're trying to minimize something, you're looking for that lowest point. All right, so it's an important formula to know. X equals negative b over 2a. Right, you just plug those two numbers from the function into that formula, and then take the x value, plug it back into the function, and that gives you your y-coordinate of your vertex. All right, whether the vertex is a minimum or a maximum, how do we know which way it's going to go? Is the parabola going to open upward or is it going to open downward? Well, the leading coefficient of our function, that a, that number that's in front of the x squared, that number right there is going to tell us which way the parabola goes, either opening up or opening down. And what determines which way it goes is whether that number a is a positive number or a negative number. Right? If a is greater than 0, right, so if that's a positive number in front of x squared, then the vertex is going to be a minimum point and our parabola opens upward. Right, so if a is greater than 0, if it's a positive x squared, so like just 1x squared or 5x squared or 17x squared, the graph's going to look something like this. It's going to be opening upward, and that vertex is going to be that minimum point on the graph. Right? If a is less than 0, so if there's a negative number in front of that x squared, just negative x squared or negative 5x squared or whatever, then we're going to have a graph that looks like this. The parabola opens downward, and the vertex is actually the maximum point on the graph. Right? So if a is less than 0, the vertex is going to be a maximum point. Right, so you can tell just by looking at the function, just by looking at that leading coefficient, you already have like a visual image of which way the parabola is going to go, upward or downward, and then whether you have a minimum or a maximum point on there. Now, if you have watched some of the videos that I did previously, I did some on graphs of parent functions and doing transformations of graphs. These rules here tie right into those. So if you're familiar with the rules for transformations of graphs, I'm going to kind of explain how this relates to that. All right, so first off, the parent functions for y equals x squared, if you recall, that's the graph that looks like this, but the vertex is right at the origin. Right, so that was the parent function y equals x squared that we used when we did transformations of functions. Right, now, what transformation makes the graph flip over and go the other way? Well, that reflection comes when I put a negative in front of my parent function. Right, so the graph of x squared, if I just draw a real quick graph here, right, this is the graph of y equals x squared. Right, it's a parabola with a vertex at the origin. The graph of y equals negative x squared flips that graph over. The vertex is still at the origin, but now it's facing downward. Right, so that negative in front of the x squared determines which way the parabola is going to go. When there's a negative in front, that means you reflect it, you flip it over. Well, same deal here. If there's a negative number in front of the x squared, it's going to be a downward facing parabola. That negative flips your regular parabola upside down. Right, whereas if it's a positive number in front of the x squared, well, a positive number, there is no reflection, so you don't flip it over. It's just that normal upward facing parabola like y equals x squared. Right, so again, seeing the connections is something I mentioned in a lot of the videos I do. Seeing the connections between the different things that you learn. A long time ago we talked about transformations of graphs and the parent functions and when to flip things over. Now you're learning these rules about the graph of the parabola for the quadratic function, but it follows the same rule. Right? A negative in front is a reflection and it flips it over. Right? And we'll see that that's going to be the case for any type of polynomial function. That leading coefficient, and whether that leading coefficient is positive or negative, will tell us whether to have the normal graph or to flip the graph over. Right? So that same rule that we learned for transformations still applies here. Right? It's important to see those connections between what seems like different topics. They're all related. Right? They all tie into each other. Right? So if you see that stuff, it makes it easier to understand and to remember what's going on. All right, so that's pretty much all the information we have on the parabola in this standard form. Again, the leading coefficient, positive or negative, tells you whether it's facing upward or facing downward. Positive is facing up, negative is facing down. A real stupid, kind of simple way to remember it is, if that's a positive number, it's shaped like a smile, right? And a smile is a positive thing. If it's a negative number, it's shaped like a frown, and a frown is a negative thing. Again, it's stupid, but it's true and it works, so it might help you remember which one is which. So that tells you, which direction the parabola is facing. The vertex, if you're facing upward, if your a is greater than 0, your vertex is the minimum point on the graph. If you're facing downward, that vertex is going to be the maximum point. And the formula to find the vertex, again, a very important formula, the x-coordinate equals negative b over 2a, which is taking those numbers from the function itself. And then the y-coordinate is f of negative b over 2a. You take this x value, you plug it into the function in place of x, and then you get your y-coordinate. Right? So that's all the information about a quadratic function in standard form. I'm going to do another video where I actually do an example of finding the vertex and figuring out whether the graph is going upward or downward, and actually probably sketching a graph as well of a parabola. So make sure you check out that other video I do with the example where we kind of see how to actually do this when you're actually solving a problem. Right, this video is more just for an explanation of what all this stuff means.